All right. Hey guys, this is Mr. Dell. I am looking at today CPM's Course 3, CC3 from Section 3.2.4, number 3-105. So number 105. So we have, you can read that there. We have a table of values, right? So here's our table of inputs and outputs, X's and Y's, and they want us to complete the table and then go through the process and find out what the rule is in algebraic symbols, as well as then graph this rule on graph paper. So we will go through this process. So they've given us some values, some inputs and outputs, some inputs and outputs, some X values and Y values. So you have an X of 1 and a Y of 24. Then you have an X of 2 and a Y of 12. So right away, I tend to just start playing around with numbers. And if I'm looking at 1, if my input of 1 increases all the way to 24, then maybe it's I would consider maybe 24 times X. So 24 times 1. But then I look at this one and say, well, that's 24 times 2 would not be 12. It's then getting smaller. So interesting enough, getting smaller, I can't use addition either here because I put a number in and now it's getting smaller. And again, I can even see 6 and that's going down to 4. So the only other thing that makes numbers smaller would be something having to do with division. But if I'm thinking that's my input, in this case, what if I take 24 and divide it by my input, right? 24 divided by 1 is 24. 12 divided by 2, 24 divided by 2 is 12. 24 divided by 6 is 4. 24 divided by 12 is 2. So I think we've got a pattern there. So we can see this pattern here to be that I'm going to take my input value and divide it into 24. I'm going to take 24 and divide it by my input, which is X. So this is one way of writing that 24 divided by X. But when we talk about an equation, we usually do not have the division symbol in an equation. So if we're going to write the rule, part B, in algebraic symbols, we would probably write it as Y equals 24 divided by X. Write it like a fraction value. Okay, so this would be a good way to write that rule, 24 divided by X. So every time I take 24 and I divide it by X, I get that output. So 24 divided by 3 would make this output an 8. Let's see, 24 divided by 8 is 3. 24 divided by 24 is 1. So I'm filling in my table in the output. So now how do I go reverse? So something, right? 24 divided by something is 6. So 24 divided by 4 is 6, right? So that's why that input there would be, the X value is 4. And I believe I've got it all. And my X, I could say 24 divided by X like that, or better yet, the algebraic rule would be here. So that's the pattern. That's the explanation is taking the, you can actually also explain for part A. You can explain it by saying the output is equal to 24 divided by the input, right? So that's another way to explain the pattern. The output is equal to 24 divided by the input. And then B, we said the rule you would write as Y is equal to 24 over X. Okay. Now, from that, C gets a little trickier. C, I want to graph this rule. So I'm going to use graph paper here, and I'm going to graph my rule. Let me make some space. And if I'm thinking about the table I have my Y value up to 24, and my X value also up to 24. Oops, let me get so you can see what I'm pointing at here. My Y value, the highest is 24. My X value, the highest is 24. So I may need to go by 2s on my scaling. So I could use a 12 by 12. Um, and if I also, the other thing that's unique is if you look, there's no negative in this set of um, values, table of values. There's no negative values. So I'm mainly going to be graphing the positive, which is the first quadrant. So let me just count and get some values here. If I'm going to go 12, 1, 2, 3, 4, 5, 6, 7. I'm going to go one more, and then I can since I'm only going positive, I'm going to put my origin right here. Put my origin there because I'm only using really quadrant 1. So there'll be my origin. And if I'm labeling my axes, let me get my graph next to my table of values here. There we go. I'm labeling my axes. I'm going to go up by 2s, 2, 4, 6, 8, 10, 12, 14, making some space, 16, 18, 20, 22, 24 is up there. Okay, and then same thing, 2, 4, 6, 8, 10, 18, 22, 24, right? So let's graph our table of values. Input is, this is some arrows on my axes, label my axes, my x-axis, my y-axis. And my first value is 1, 24. So 1 on the x, 24 on the y. Oop, let me use a different color to graph that so we see it. So that would be that point there. This point here, 2, 12, 2 on the x, 12 on the y. Okay, 3, 8. So 3 on the x, 3 is between 2 and 4, and 8 on the y, 4 on the x, and 6 on the y. Let's see, so we've got 5 in between 4 and 5 at 4.8, which looks like probably right about there. And then 6, 4 is here. 8, 3, 8, 3. And what else do I have? I have 12. 12's here, 12, 2. And then I go to 24, 1. Look at that pattern. That's an interesting pattern, isn't it? So it wants us to kind of describe this shape. So if we think about what does this shape look like? And the other question I would ask you is, do I connect the dots for this? If my rule is y is equal to 24 over x, is it possible to put in a 10 into the x, right? I can put 10 into x in the input and come up with 2.4, right? If I put 10, I'd have 2.4. I would have a point there. So what if I put in, could I put in, let's say, 14 and a half, right? If I put 14 and a half, will I get a value up here? I sure will. So really those points do connect, and they kind of draw this curve. It looks like the pattern is a curve like so. Now, does it continue on? Could I put a value in here of 1/2 into x? Yeah, if I put 1/2 in, I'm going to get 48 as y. So really it does continue. So I'll just throw some arrows, and then could I put a value of 48 into x and get a value for y? I should. I'd have a half. So I'm going to just throw arrows to show that pattern kind of continues along. So our shape is a curve that continues along the x and y axes in the positive direction, right? So that's how I would describe my shape, is this curve that continues along the x and y axes.